Voyagers took some of the first detailed snapshots of planets and moons. And after cruising for over 43 years with 18 billion kilometers traveled, they're taking humanity into the next great beyond, interstellar space. The Voyager probes are two obscure-looking robots, weighing about 800 kilograms with giant arms and big ears designed to sense what's out there. And it took 1,500 engineers and scientists to bring these robotic explorers to life.
I started working on Voyager right out of college. It was my very first job as an engineer.
Good morning, and welcome to the 5 o'clock edition of Voyager Update. I'm your host, 𝓲𝓮.
So Voyagers were really developed in the early 70s. They were launched in 1977, and the original goal was just a 4-year mission to explore the Jupiter and Saturn systems.
With the possible opportunity to go further out to Uranus and Neptune, the NASA engineers developed a mission within a mission, outfitting the probes with 11 different instruments with redundant systems and autonomous controls. They also each carried a golden record for a potential extraterrestrial to decipher.
That's a time capsule of us here on Earth, and if any other being were to find it, they would know what we on Earth were like in 1977.
We have liftoff of the Titan Centaur carrying the first of 2 Voyager spacecraft to extend man's senses farther into the solar system than ever before.
As they hit each planet, Voyager beamed back observations of Jupiter's turbulent atmosphere, Saturn's moons, and Titan's hazy layers.
I really think that the Neptune encounter was probably the most significant thing in my career. I was involved with all the design on the closest approach sequence. I really felt like I owned what the spacecraft was going to execute, and it went flawlessly. We got a big send-off afterwards. The Planetary Society had Chuck Berry come and play because, his Johnny B. Good song is on the record, and I'll always remember that as one of the highlights of my career, if not the highlight.
As the Voyagers cruised beyond our neighborhood, Carl Sagan convinced NASA to tell Voyager 1 to flip its camera around and take the first planetary family portrait. That's us, 6 billion kilometers away, the pale blue dot. And that should have been the end of the mission. But to everyone's surprise, the Voyagers kept going, entering a place no one had ever seen before, the final frontier.
Since flying past all the planets, we turned off the instruments basically that were designed to take pictures and repurposed the memory for this long Voyager interstellar mission. The space beyond the planets is very empty, very dark, very cold, and as you travel further and further, you see less strength of the sun. The heliosphere is the bubble of charged particles around our star, our sun. And they expand out, and then eventually they stop. And they stop due to the pressure from the interstellar medium and the wind from the interstellar medium. And the interstellar medium wind is actually created by exploding stars, supernova. All the other stars and material that are out there are pushing on our bubble, and that is what keeps the shape of it.
In 2012, Voyager 1 started detecting changes in its immediate environment.
We started to see dropouts in particles from the sun and increases in particles from the interstellar medium. And they drop down, and then they go back up again. And then on August 25th of 2012, they just dropped down and stayed down. And similarly, the particles from interstellar space do the opposite. They bumped up and they stayed up.
The plasma instrument on Voyager 1 wasn't working properly, so it was hard to confirm if it really crossed the boundary.
There was a lot of debate, and by a nice coincidence, there was a solar flare that happened 13 months previously, finally reached Voyager 1, and that solar flare excited the plasma around the spacecraft. That was when the particle instruments said, hey, we're in interstellar space. We see the change in the particles. Voyager 2 has an active working plasma science instrument. So we saw the density in the plasma change almost instantaneously.
As they travel through the interstellar medium, the sheer scale of the universe really comes into perspective.
Studying the interaction of our star, our sun, with what's beyond it. And when you study our sun, you're studying the energy that's giving us life here on Earth.
Voyager 1 detected unexpected pressure at the edge of our solar system for the first time, giving scientists clues about the dynamics we might find in other star and planetary systems. To keep data like this coming in, the Voyager flight team has to make careful energy management decisions.
We use a nuclear power source that decays at 4 watts per year. And so one of our biggest concerns now, and what will really limit the lifetime of the mission, is just how much power the spacecraft has to continue operations. We also have to pay attention to the temperature of the spacecraft. We don't want to freeze the propellant lines that we use to keep the antenna pointed at the Deep Space Network. It's 20 hours to get the signal from Earth to the spacecraft and 20 hours for the spacecraft to turn around and acknowledge that they got that signal, which really means that the Voyager spacecraft have to be autonomous. They have to be able to sense for themselves what's going wrong, put itself in a safe state. It feels like it's under stress. Our day-to-day engineering activities relate toward keeping the spacecraft warm enough, making determinations of whether we have to turn off another instrument heater or not, and then which instrument would you turn off. All these instruments have been on since 1977. Now, these principal investigators who are in their 80s now, they don't want to see their instrument turn off.
The Voyager engineers are still manning this mission today until the signals eventually stop.
One day we'll come in to the office and it won't be there. And that will be the loss of the spacecraft. And that will be a very sad day, but also one where you can reflect on how great the mission was. I think Voyager has touched humanity in many ways. And I think that connects us as humans to space exploration.